Okay, so this question, they ask what? They ask what are the partial pressure of NO gas, O2, and NO2. So the first thing, they did give us a diagram here. So we know that the NO and the O2 are separated through a valve, right? And they gave us volume, they gave us the pressure of each of that. So let's just write down the equation. Okay, so all of these are guesses, okay? Now, we know that we can use the gas law formula, which is what PV equals to nRT. Therefore, N equals to PV over RT, right? So using the gas law, if we have enough information, we can find the mole, okay? So the mole of NO here is what? The pressure of NO. So pressure of NO is 0.500 atm. And then you have the volume of NO is 4.00 liter divided by what? The R, which is 0.08206 atm liter over mole Kelvin. And then you will have what? Temperature. So the temperature given here is 25. So 25 degrees Celsius, you want to change that into Kelvin. To 25 degrees Celsius plus 273.15. That's going to give you, it's Celsius, it's degree, not zero, okay? So it's going to give you 298.15 Kelvin. So use that 298.15 Kelvin. So you can see that all the units gonna cancel out, and you are just gonna be left with mole, and the mole is gonna be on the top. So this is gonna give us, just check, 0.0817. Okay, so that's gonna give us the mole of NO. Now, same thing, we want to find the mole of O2. The same thing, PV over RT. So pressure here is 2 liter. Sorry, my bad. Pressure here is 1 atm and the volume is 2 liter. So just write it there. Pressure 1.00 atm into volume 2.00 liter divided by R, 0.08206 atm liter mole Kelvin. Into same temperature, remember? They all are in same container, so temperature is same. So into 298.15 Kelvin. And this is also going to give us 0.0817 mole. Okay, now we already have the mole, okay? Now let's just take out our formula here. The chemical equation shows 2NO plus O2 becoming 2NO2. And let's put the moles down. Okay, so we have 0.0817 mole. Same here as well, oxygen 0.0817 mole. So both of them have the same mole, but one of them is going to be the limiting reagent. And how do we figure which is the limiting reagent? We divide it by the coefficient. So here you have 2. So just divide it by 2. Okay? Just divide it by the 2. Or let's just write it down again. 0.0817 divided by 2. And for oxygen, you just divide it by 1 because this is just 1, right? So the one that is going to give you lesser number. So which means what? This is going to give you lesser value. So that's going to be your limiting reagent. So, but we don't want to use the number from this calculation, okay? We want to just use the number of mole. So here, the number of mole is what? This one. So this is the limiting reagent. Okay? So now we can erase all this that we already find our limiting reagent, right? So this is our LR, limiting reagent. Okay. Now, using the limiting reagent, we know that we can find how much of NO2 is going to be produced, and also how much of O2 going to be consumed, because why? The thing from the reactant is going to go decrease, and the thing from on the product is going to go increase. So we know how much NO2 is going to be produced and how much of O2 going to be consumed. So let's see. So we know that NO is the limiting reagent. That means what? That means the whole thing of NO is going to go and be used in the reaction. So it's going to be used 0.0817 mole. So this is going to give you 0 mole. Okay. And about the O2, how much is going to be used? Okay, for that we need to do our ratio. So we started with what? Our limiting reagent, which is this one. So let's just take that 0.0817 mole of what? NO. Multiply with 2 NO on the bottom, 1 O2. So this is gonna give us what? This is gonna give us, just give me one sec. Okay, this is gonna give us equals to 0.04085 mole. Okay, so yeah, so this is gonna minus 0.04085 mole. And the remaining gonna be what? 0.04085 mole of O2. And what about the NO? Now for NO also, we need to do the ratio. So we started with 0.0817 mole of NO. Why NO? Because that's our limiting reagent. On the top, we're gonna write 2NO2. On the bottom, 2NO. This is gonna give us 0.0817 mole of NO. So let's just write that. So previously it was what? 0. And then we increase with 0.0817 mole. So at the end, we have what? 0.0817 mole. So, okay. So we have the total number of moles. So we're good there, right? Now what do we do next? Now that we have the mole, we can find the partial pressure. And the way we are going to find the partial pressure is we are going to again use the gas law. Okay, we again going to use the gas law. So PV equals to nRT. So P equals to nRT over V. Do we have the volume? Let's see. Do we have the volume? Yes. Okay, why am I using the partial pressure here and not the Dalton's law? That's a good question. Because the volume here is going to be constant. Because the volume is constant, it's not going to change, right? Unlike in Dalton's law, it might change. Because the volume is constant here, because of that, we can use what? PV equals to nRT. Okay, because the volume is constant. So now we cannot use the pressure because the pressure might change. So the total pressure might not be 1.5, even though you have 0.5 here and 1 here. They do not add up to be 1.5. But the volume is always going to be constant, right? So you have 4 here, you have 2 here. So it's always going to be 6 liter. Even when you open this, open the valve, it's still going to be 6 liter, right? So what we're going to do, we have total volume of 6 liter. Okay, now what we do, we find the pressure of each of that. So first, because we know that there is no remaining NO, right? So for NO, because there is no remaining NO, the mole is going to be 0. So 0 multiplied with anything and divided with anything doesn't care. It's just going to be 0. So the partial pressure of NO is 0. And then the partial pressure of what? O2, right? it's gonna be, now put the O2 mole, which is what? The remaining, okay, we're talking about the remaining. So 0.04085. 0.04085 multiplied with the R constant. 0.08206 multiplied with temperature. 298.15 divided by volume, which was 6 liter, right? Okay. And this is gonna give us 0.165 atm. Same thing we do for PNO2. So we have what? What's the mole of? So we have 0.00817. 0.0817, and then we multiply with the R, which is the constant, gas constant, temperature the same, and volume the same. And this is gonna give us 0.333 atm. Okay, so that's how we get here. So it is because the volume is constant and pressure can be changed, right? Because we have a constant volume, constant container, we need to use this even though we are finding the partial pressure. I hope you understand. Thank you.